Throwing one giant prompt at an AI works for basic tasks, but the approach often breaks when you try to build a complex application. This setup introduces a strict three-layer framework, a global constitution at the top, modular blueprints in the middle, and short incremental prompt loops at the base. These layers ground the model, keeping generation focused and preventing the AI from inventing features outside your scope. Adopting this layered structure shifts the workflow from unpredictable generation toward a disciplined engineering process capable of scaling to full-stack applications. The first layer is the agent.md file. This global constitution defines the tech stack, data models, and non-negotiable rules for the entire project. In Lovable, you enforce these rules by pasting your Markdown text into the knowledge field under project settings. This ensures every subsequent prompt is anchored in your core logic. You use this file to lock in global constraints, such as requiring a human in the loop for critical actions like grading or data deletion. The second layer consists of skill.md files. These are isolated blueprints for individual modules, such as a passage creator or an analytics dashboard. Each skill document must specify the exact inputs, the required outputs, and the database tables the module will interact with. Avoid vague instructions like "make it adaptive." Instead, write out an explicit formula, such as promoting a student only when their mastery score reaches 0.8. Separating global laws from specific math-based rules limits the AI's ability to invent opaque or unexplainable logic. To begin the build, prompt the AI to read the knowledge file and scaffold the application. This initial scaffold should generate only empty dashboards and set up basic user roles. Do not add any features yet. This architecture map shows the division of labor. Lovable builds your React frontend, while the backend is handled by Supabase. Supabase manages your authentication and database requirements, which allows the AI to focus entirely on the front-end interface. Keep this initial setup completely devoid of specific features or complex logic. Establishing a clean, structurally sound foundation ensures that all subsequent modules have a stable environment to attach to, without creating conflicts. With the scaffold ready, enter the execution loop. Feed the AI one skill blueprint per session. Use a critical prompt habit. Force the AI to list the files it plans to change and wait for approval before it writes any code. After a module is complete, ask the AI to summarize the work and update the knowledge file to keep the project context current. If the AI generates bad code that breaks the application, prioritize reverting to a previous state over attempting a patch. Use the platform's version history tool as a strict undo button. Do not prompt the AI to fix its own mess. Attempting to patch a bad generation often adds unnecessary complexity and compounds the AI's contextual errors. For the final step, prompt a full audit of your row-level security policies. This audit ensures that sensitive user data remains strictly siloed and protected from unauthorized access. This cycle of controlled prompts, human approvals, and security audits transforms raw generation into a professional software development cycle. This process results in a secure, full-stack application that avoids the technical debt created by unstructured prompting. Your first task is to draft your global constitution and your initial module blueprint. Do not write a single line of code until these two core documents are finished. Engineering a rigid system provides more reliable speed than rapid code generation. By forcing the AI to operate within these predefined technical boundaries, you minimize the logic errors and scope creep common in unstructured development.